want to spend a ton of time because you guys talked, well, I do want to talk about applications today of polynomial equations. That's kind of the topic of the day, but I want to also take a second and just review solving polynomial equations. Okay, stuff you guys talked about yesterday. So, our phones up front, I'm assuming. If they're not, do that real quick. If you forgot, it's easy to forget. Okay, click those Chromebooks closed. So let's review, first of all, factoring polynomials. What's kind of our checklist, our protocol when we're trying to factor a polynomial? First thing we always try to do, GCF. Always factor out a GCF if you can. It always helps. And then the next step is going to be dictated by how many terms there are. If there's 2 terms, then you're going to try to use one of our binomial factoring patterns, right? Either they're going to work or they're not. If there are 3 terms, if it's a basic trinomial where a is equal to 1, then you're just looking for some magic numbers. Either they're going to work, you're going to find them, or you're not. If a is not equal to 1, if it's a tougher trinomial, then you're going to try to split and group. But really, you're going to try to find magic numbers, first of all, that allow you to split and group. And if you can't find magic numbers that multiply to the product of the outer coefficients and add to the middle coefficient, you're done. It's just not going to factor. And then if there's 4 terms, you're going to try grouping. And of course, we would just do our test to see if it's going to group, right? We would do the exponent, what do we call that? The exponent drop test, and then the coefficient test. Just by, by inspection, we say in math, just by inspecting it and doing those quick tests, should I group? Is it going to work? If it passes those tests, if the exponents drop by the same amount in group 1 and 2, and if the ratio of the first 2 coefficients is equal to the ratio of the last 2 coefficients when it's in standard form, then grouping is guaranteed to work, and so you factor by grouping. And then once you're done with all that stuff, you see if you can go further. See if any of those factors could be broken down any further, factored any further, right? So we've had a lot of practice with that. Did we do one like that yesterday? Did you remember going through one like that? Okay, we don't have to go through the whole thing, but what would your strategy be here if that's what you're starting with? Good. So first of all, we'd have to distribute and subtract 5 because our goal is to put this into standard form, right? We're going to make this a polynomial equation in standard form, which is, which is that, right? And then we would just try to factor that thing and set the factors equal to 0 using the 0 product property. So give me 1 to 5 on something like that. How are you feeling about one like that? Okay, good. All right, we won't spend time on that. How about one like this? So I don't think you did one like this. Let's just review how to do one like this real quick. So if we start off with this equation at the top, first thing we would do is move everything to one side and put it into standard form, right? And when I say standard form for an equation, what does that mean? What am I trying to set it all equal to? All equal to 0, good. And the other thing is the exponents have to go in decreasing order, good. Equal to 0, and we write the terms where the exponents go in decreasing order, good. Okay, now how many terms in this polynomial? 4, okay, so we're going to try what technique then? Grouping, is it going to work? Give me thumbs. Yeah, it's going to. Exponents drop by 1 in each group, and 1 divided by -9 is equal to -1 divided by +9, right? So we know it's going to work, so we just go through the process of grouping. Well, what do we do first? Okay, good. So first step, well, I guess first step is we're going to separate the groups. Then we factor out a GCF from group 1, which is x squared, good. Okay, and then what's left behind? X minus 9, good. And so what do we do in group 2 then immediately? Good, we're going to carry that x minus 9 to the other side, okay. And so what do we have to factor out to make that happen? There you go, -1, good, okay. And so we got this thing down to here. And now what, last step? Okay, good. Yeah, we'll factor out of each group, we'll factor out that x minus 9, right? Which leaves us with an x squared minus 1, okay? Now what? Set both equal to 0. We can do that, by the way. We haven't really talked about how to solve equations like this. We're going to focus more on solving quadratic equations next chapter. So when we set these equal to 0, we either get x minus 9 equals 0 or x squared minus 1 equals 0, right? We don't yet, you guys might remember, but we haven't really talked about the shortcut way of solving that. So we may not be done factoring, at least for now, right? Eventually we may be able to stop factoring and just solve, but we'll get to that next chapter. Blue factor is done. How about the red factor? Could I go further with the red factor? What could I do with that one? There you go. It's a difference of squares pattern. X squared minus 1 squared. Good. So we could break that up a little bit further. And now we've got this thing completely factored. How do we find the solutions once we've factored the polynomial completely? There you go. Apply the zero product property or the zero factor property, whatever you want to call it. We set each factor equal to 0 and solve. And we get 9, 1, and negative 1, right? Okay, give me thumbs. That'll make sense? Okay, good, good, good. It would, yeah. And we'll get to that next that's one of the techniques for solving quadratic equations. You guys might even remember how to do that a little bit, but we'll go through that. We'll review all that next chapter. Yeah. How about this one? You guys did one like that?
I don't know.
Okay, so should we do this one?
Yeah.
Okay, good. Okay, so if we're going to solve this one, what's the first step? Well, no. Yeah, get it equal to 0, first of all. Put it into standard form. That's our first step. Okay, so we're going to do that. Okay? Now what? Okay, factor out the GCF, which is an x, right? We always want to factor out a GCF. Good. So we factor out an x, and then we're left behind with an x squared minus 16. Difference of squares. Very good. So we'll factor that x squared minus 16 into what, everybody?
X squared minus 4 x cubed plus
X minus 4
plus
x plus 4. Good, because that's x squared minus 4 squared, isn't it? Good. Good. Okay, and now we got answers. So what are, show me with your fingers here, what's the solution to my first factor?
4.
No, 0, right? The first factor is the GCF that we factored out in the beginning, that monomial. So when is x equal to 0? When x equals 0. There you go. Okay, so there's 1. X equals 0. What's the next solution? The 0 of the next factor? Negative 4. There you go. Okay. X plus, so I guess oh darn it, I didn't want to do that. Right, so then that's going to be the solution to that equation, x equals negative 4. And then finally, the last solution would be positive 4. There you go. Good. Okay, good, good. All right, so now let's move on to some applications of these polynomial equations. Why have we been studying these? Well, so we can answer some interesting questions. So here's one. This is a good one. This is a physics problem, a projectile motion problem. The height h in feet of a golf ball after t seconds, so after it's been hit, t seconds after it's been hit, is given by this model, this equation. H equals negative 16t squared plus 96t. Find out how long it takes the golf ball to return to the ground. Okay, so if we wanted to kind of break, and I'm always a little bit leery about this, about these recipes, but at least initially it's helpful. So when we're trying to do problems like this, we could break it into some steps. Our process is broken into steps. First of all, we want to really take time and digest the problem. This is important. I think I've talked about this a little bit before, but you guys are all massive overachievers, and so you just want to get in and get the work done immediately. And so sometimes that compels you to jump into something before you're really ready to do it, right? I think I told you the story about my son, you know, his freshman year. He had a math problem in one of his classes. He had to just stare at it literally for like 3 hours without doing anything before he finally knew what to do. You're not going to have to do that in here, but you might have to stare at it for a few minutes, right? I mean, to really kind of think about what's going on. That's first step. Next step is we're going to translate this. We want to move this from an inconvenient, cumbersome problem involving words into a really efficient problem that's completely mathematical. We want to, convert this, translate it into a math equation, and then we can just kind of shift into algebra mode and solve that math equation. And then finally, when we're all done with our math solution, we got to go back to the real world and sort of interpret our math solutions. How do those relate to the problem that was originally asked? Okay? And that's kind of the process we go through. So first of all, understand this. What can we say about this problem? How long does it take the golf ball to return to the ground? What are we really looking for in this case? Okay, how do we know when it ends? Say it again? Okay, when the height is 0. Okay, good. All right, so first thing would be we're gonna read and reread the problem, and we want to figure out when h is equal to 0, right? So we want to know what value of t makes the height equal to 0. So we're just going to solve the equation h equals 0. Okay, well that's h is equal to this expression, so negative 16t squared plus 96t equals 0. That's what we're solving. Now we can just flip into math mode and go to town, right? So what do we do to solve this thing? Okay, what is the GCF?
14, 16.
Okay, what's the sign of the GCF going to be? The sign, it's negative, right? Because remember what we said a long time ago, well, not that long ago, when we're talking about GCFs. The GCF always inherits the sign of the leading term. So if the leading term is negative, we want to make our GCF negative. Okay, so the first thing we're going to do is we're going to factor out a negative 16t, which leaves behind t minus 6. Okay? All right, so we've factored the polynomial. It's in standard form. It's equal to 0. So by the zero product property, what are our solutions? 6, t equals 6, or 0. Yeah, okay. So those are our mathematical solutions. Well, I mean, talk to me about those solutions. Yeah, okay, so which one are we looking for? The higher one, right? It takes 6 seconds for the golf ball to return to the ground. That first one, is it just nonsense? It's not. The math gods are wise. I mean, they never give us superfluous information. It actually is something that is legit. It's just not the one we're looking for. What is the height of the golf ball at t equals 0 when it's on the tee and you're hitting it? 0. Yeah, it is 0 at t equals 0. That's just not the instant that we're interested in. We're interested in the moment in time when it returns to the ground after having been hit, right? So this is the one we're asking about. But the other one is meaningful. It's just a different question. Okay? Give me thumbs on that. Does that make sense? Okay? So we interpret then, and the answer is after 6 seconds, the golf ball returns to the ground. And we got it. Okay? What else did they want to know? Anything else? I guess that's it. Okay? Okay? Okay, good. And if we wanted to check our solution, of course, we could plug 6 into the original equation and it would give us h equals 0, right? Okay, let's try another one. Okay, how about this one? The product of 2 consecutive positive integers is 132. Find the integers. Okay, so what are we trying to do here? And go ahead. And
Consecutive means that they're like right after each other.
okay, that they're consecutive means that they go in a row. So 2 integers that are in a row when I write a list, right? Okay, so how could I set this thing up then? Okay, so if I call the first integer x, the next one, if it's consecutive, has to be just 1 bigger than that. It's the right. Integers always increase by 1. So x is the unknown positive integer, then x plus 1 is the next positive integer. So what can I do with those? Okay, so their product, the product of those two integers is 132. So doesn't that give us the equation x times x plus 1 equals 132? Everybody agree? Okay, good. Okay, so we're going to solve this thing, right? So we're solving the equation x times x plus 1 equals 132. So now we shift into algebra mode. We don't have to think about the application for a while. We're just going to shift into algebra mode and solve this thing. What do we do? What do we have to do? Okay, distribute the x. Good.
Make it 0.
And then I got to set it equal to 0, right? Okay. There's sometimes people want to do something like they want to apply the zero product property when the other side is not 0 and say either x equals 132 or x plus 1 equals 132. That doesn't work, right? It's not we don't have a separate property called the 132 property or product property. We only have the 0 product property. So we have to eventually set all this stuff equal to 0. We distribute the x, we subtract 132. Now we've got a polynomial equation in standard form. It turns out this is a quadratic polynomial, so eventually we'll just call this a quadratic equation in standard form. How are we going to solve this one? Okay, what are those numbers that multiply to negative 132 and add to 1? They must differ by 1, right? Because they multiply to negative 132 and add to positive 1. So I've got a positive and a negative.
Negative 12. Because I know that 11 is 11. Negative 11 and 12.
11 and 12? That looks pretty good. Looks pretty good to me. X plus 12 times x minus 11. Okay? Make sense? So my solutions then are either x equals negative 12 or x equals positive 11. Are we done?
No.
No, we're not. Right now we got to go back and interpret. Okay, now my original question said that we were finding positive integers. Okay, so what does that mean? Well, that negative 12 is not a valid solution for us because we're looking for positive integers. Now, it might be valid mathematically, but we have some stipulations here, some constraints. We're only looking for positive integers. So we're going to discard the negative 12, right? Because it's negative, and we'll keep the positive 11, right? So if x is 11, then x plus 1 is 12. And yeah, sure enough, that works. 11 times 12 is 132. Okay. What are two other numbers, not necessarily positive, that would have worked? Yeah, negative 12 mathematically was a legitimate solution. Negative 12 plus 1 would have been negative 11. And that product would have worked, only they're negative, and we needed positive, right? Okay? Give me thumbs. That'll make sense? Okay, good. All right, just a few more of these to practice. Okay, so first of all, quick review, Pythagorean theorem. You guys all know the Pythagorean theorem. The sum of the squares of the legs of a right triangle is equal to the square of the hypotenuse. In other words, a squared plus b squared equals c squared, where a and b are legs and the hypotenuse is c, right? Okay, so let's use that. What about this one? It says, find the length of the shorter leg of a right triangle if the longer leg is 10 miles more than the shorter leg and the hypotenuse is 10 miles less than twice the shorter leg. Okay, well, what are we trying to do here? Okay, so now, suggestions. Okay. Okay, good. I'm hearing good stuff here. So first of all, when you read this thing, what's the only side of that triangle that we know nothing about? The shorter leg. The other sides of the triangle, we know something about them. We know how they compare to the shorter leg, right? But we know nothing about the shorter leg, so which variable should we set x equal to then? The shorter leg. Which side? The shorter leg, because that's the one we know nothing about. Good. Okay, so what's the length of the shorter leg in terms of x? Well, it's x, isn't it? The shorter leg is x. So if that's the case, what's the length of the longer leg? x plus 10. Yeah. Oops. And then, of course, the length of the hypotenuse, I guess somehow that one already got deleted here. Hypotenuse is 10 miles less than twice the shorter leg. Well, twice the shorter leg is 2x. 10 less than that means I have to subtract 10 from that, right? 2x minus 10. So there's my triangle. That's what I would want to draw a picture of. Pictures are great. If you have a geometry problem, you always try to write out a picture including the variables. So there they are. Okay, so we got our triangle in terms of x, all the sides written in terms of x. What can I do with that now?
X squared plus x plus 10 squared equals 2x.
Yeah, okay, we'll just apply the Pythagorean theorem, won't we? Right? So leg squared plus leg squared equals hypotenuse squared. So the short leg squared plus the long leg squared equals the hypotenuse squared. Okay, that's an equation with variables in it. We can shift into math mode and solve. What do I have to do to solve? Okay, I can't just distribute here, though. I think you are thinking the right thing, but I need to expand those out, those binomials, right? I need to expand out x plus 10 squared and 2x, the quantity 2x minus 10 squared, using our product patterns, right? This would be a plus b quantity squared, and this is a minus b quantity squared, right? Okay, so what's that going to give me then? There's my equation. Plus 10 squared. So it gives me, everybody agree that this stuff right here becomes that stuff right there, right? On the other side, a minus b quantity squared is a squared minus 2ab, so 2 times 2x times 10. Wouldn't that just be negative, 40x? I'm subtracting 40x. Plus b squared, 10 squared is 100, right? So all this stuff just turns into that. Give me thumbs on that. Does that all make sense? Okay? Now what? Set it all equal to 0. Okay, which side am I going to...
Easier to combine like terms first.
Maybe, yeah, combine like terms. That sounds good to me. Okay, so let's combine like terms. Good. And now what?
And now
Set it equal to 0. Now, they probably move it to the wrong... Oh, no, they did it right. Okay, so which side should we move everything to? I don't know. I'd say the right side. How come? Because we want a positive coefficient of x squared to make things easier, right? So we would actually take all these terms and subtract them to the right side. So 4x squared minus 2x squared is 2x squared, right? Negative 40x minus 20x is minus 60x, and 100 minus 100 is 0, right? Those guys cancel. So we end up with that equation. Everybody agree? Okay. Now what? We got a polynomial equation in standard form. Okay, what do I have to do first? Okay, I can take out a 2x, can't I? Yeah. And it's important to take that x out. If I take that x out, this gets pretty easy. If I undistribute 2x, I'm just left with x minus 30. So I don't even have to use any fancy patterns. I've got an answer now in one step. What's the 0 of the first factor? 0. What's the 0 of the second factor? There you go. So my solutions are 0 and 30. Okay, so mathematically at least, right? Okay, so let's interpret that. Yeah, how come not 0? That things kind of collapse at 0, don't they? This is a pretty funny looking triangle if one of the legs has length 0. Doesn't it kind of cease to be a triangle then? Right? So even though this is a mathematical solution, x equals 0, it doesn't work geometrically, so we discard that one, right? So we get the solution x equals 30, and then if I plug that value of x in, I can find the lengths of all the sides, right? So if x is 30, then the long the longer leg was x plus 10, so that's 40, and the hypotenuse was 2x minus 10, so that 60 minus 10 is 50, and we got it. We got all our lengths. Okay, give me thumbs. That'll make sense? Okay? All right, one more. Oh, okay, this isn't even, I just wanted to review something here. You guys, you guys remember how to do this stuff? We haven't done it in a while, and I wanted to just force you to kind of deal with this old concept because I don't want it to go away in your brain. So how could I figure out which function goes with which graph? What's my thinking?
Find the leading variable.
Okay, I got to find what's the leading term going to be, right? So this first one, f of x, if I were to expand everything out, what's the first term? Yeah, good. I get x cubed plus a bunch of stuff. How about g of x?
X cubed.
Yeah, it's just going to be x cubed plus a bunch of stuff. And how about h of x? Plus a bunch of stuff. Okay, so right away then, good. A has got to be h, doesn't it? Everybody agree? This has got to be h of x. How could I distinguish between the other two? Okay, where the x-intercepts are, right? If I set those functions equal to 0, the zeros are the x-intercepts. So which one is b? Is it f or g? It's got to be f, doesn't it? Because how do we know? Because that first 0 is at, what's the 0 of the factor x? At 0. Well, look, this one has an x-intercept at 0, doesn't it? So that's f of x. And then this must be g of x, which makes sense. My x-intercepts would be at 1, 3, and negative 3, which matches up with those x-intercepts, right? Everybody see that? Okay, give me 1 to 5 on that one. Is that ringing a bell? Okay, good. I'm going to let you work. Assignments up. Go.